Okay, this is only going to be a short video, but I just felt it was important that we covered it to make sure I've got everything basically. You need to understand about work and power and understanding the differences between them. In science, the term work done or just work has a very specific meaning. Work done is another way of saying energy is being transferred or transformed. Lifting weights transfers energy to the weights, and we can say work has been done on the weights. If you just got a broom and pushed it along the floor, you are doing work. You are transferring energy through that broom. When you lift up weights, you might transfer 100 joules of energy to them. This means the work done on the weights is 100 joules. Work done, just like energy, is measured in joules. Anything to do with energy is in joules. If no energy is transferred, then no work is done. So if you don't push the broom, you're not doing any work. You're not transferring any energy or any joules. Other examples of doing work include climbing stairs, pushing a trolley at a supermarket, or pulling a sledge along the ground. Work is always done when a force is used to move something through a distance against an opposite force. The amount of work done on an object depends on the force applied and a second factor, and that's the distance it moves in the direction of the force. So as you can see with a little calculation here, work done equals force times distance moved. So work done is in joules, force is in newtons, and distance moved is in meters. So the distance moved must be in the same direction as the force. If you just thought about a book, if you were lifting a book off a desk, for instance, the weight of that book would be the force. You would transfer the book up, pick it up in one direction. That's the amount of work you've done, and you could calculate the distance that it travels, and you could put that into your example. Now if we look at the difference between work done and power, because some people do get confused with this. We've mentioned power in previous topics when we've been looking at electricity. Power, like work, means something different in scientific language from its everyday use. A politician may be a very powerful person in terms of governing a country, but they are likely to be much less powerful physically than an athlete, for instance. In the scientific sense of transferring energy, a powerful person or device can do a lot of work in a short space of time. Power is the work done in a given time, or the rate of doing work. A more powerful kettle will do more work in a certain time. It will transfer more electrical energy to heat every second. This means the water will boil quicker. A more powerful car transfers more chemical energy in the fuel into kinetic energy per second. This means it can accelerate more rapidly to a high speed. If you remember, I said to you power has a W in it, so power is measured in watts. That's the way I remember it. So the W in power means that's the unit, it's watts. And 1 watt is 1 joule of work done or energy transferred every second. So a 1500 watt hairdryer transfers 1500 joules of energy every second. A large TV may have a power output of 120 watts, an average family car 75,000 watts, and an express train a huge 12 million watts. So work done is measured in joules, power is measured in watts.